Hello, my name is Leut Milski, and I will be presenting our work, Reasoning about Human Behavior in Ad Hoc Teamwork. To start off, ad hoc teamwork is a multi-agent problem in which agents are able to efficiently and robustly collaborate with previously unknown teammates and without having prior coordination between them. Within ad hoc teamwork research, there have been many different optimizations to enable autonomous agents to better predict what each agent is doing. We chose to take this problem and see how humans would act when collaborating with other agents in ad hoc settings. This research is important as we see people becoming more integrated with technology, specifically robots and other artificial agents. Because humans will not always act the most efficiently, our end goal is to create a model of human behavior. This model can then be used for better prediction and planning. In order to see how humans act in these settings, we utilized a specific ad hoc teamwork setup called the tool fetching domain from our previous work. Here, instead of having two artificial agents, we have one human and one autonomous agent working together. We measured the participants' performance in terms of optimality and legibility. Here is an example of the tool fetching domain. We begin with the possible goal positions, green and red. There is a worker, a doctor, who must go to one of the patient's room as specified by some instruction. There is also a fetcher, a robot, who must get the correct medicine for that patient from the medical cabinet. The robot doesn't know what the doctor's goal room is initially, but tries to determine the goal based on the doctor's path. We chose to put a human in the doctor's role because it allows us to see if they can reason about the plan of the robot as part of their decision-making. In this instance, the doctor has many choices as to how to get to the green room. This orange path is an example of an optimal path, which means that it has the minimal number of steps the doctor must take to get to their goal room. This purple path is an optimal path and also legible path. Not only that the path has the minimal number of steps to the goal station, but it also shows the robot where the doctor's goal room is as soon as possible. With the orange path, the robot does not know which room is the correct one until the robot moves to the left after 4 steps. But on the purple path, the robot knows the goal is the green room right after the doctor takes the first step to the left. We tested 3 conditions with 15 participants per condition. The first of these is the baseline condition, where the participants were only given simple instructions that mentioned what their goal was, but did not mention that the robot is trying to predict where the doctor is going. The second condition is the incentive condition. In this condition, we added bolded text in the initial screen that mentioned a bonus for the top 10% of participants. We also included bolded text in the instructions mentioning how the robot is trying to predict where the doctor's goal is. These instructions can be referred to as local information, as they provide information about a specific decision that the robot is making. Third is the instruction condition. Here, participants receive the same basic instructions, incentive, and local information as with the previous one, but we also included more bolded text in the instructions dictating that the main goal of the doctor is to act in such a way that the robot can predict where the doctor is going. These instructions can be referred to as global information, which describes the overall policy and preferences of the robot. For each of these conditions, participants partook in 16 different instances of the tool fetching domain. We separate these instances with different sizes, number of stations, and which station was the goal station of the doctor. More details and the experiments can be found in our paper. As a summary, we initially wanted to see how humans behaved under ad hoc teamwork settings. In order to test this, we had 3 different conditions and we measured the results based on optimality and legibility. We found that humans would not act optimally all the time, but they would act more legibly given explicit global instructions on how to act. If you have any questions, please feel free to contact me or the other authors. Thank you.